Hey everyone, I am Uzaifa Khan, Big Data Operations Engineer here at Cloudera. In this video, we are going to go over building an end-to-end data ingestion pipeline for this use case. Let's first quickly walk you through the working of the data flow, and then we dive into creating the NiFi pipeline right from scratch. So without further ado, let's get started. The data flow starts with a process group. Inside the process group, we have defined a generate flow file processor that creates different flow files, scheduled to run every 10 minutes. So this generate flow file processor is configured to use CM Impala API to fetch the Impala query data. Next, the toUpdate attribute processors placed next in the series declares different variables and brings all the API elements together to form a working CM API URL. Back to the main canvas. So the control rate processor configured after the process group helps in controlling with the data flow. Let's say you have an Impala intensive environment. We recommend that you use control rate when implementing this data flow. Next, the execute stream command processor is simply running a curl command against the CM API URL that generates the Impala-wide query data in JSON format. The next three JSON-related processor fetches, splits, and transforms the JSON Impala data obtained from the execute stream command processor output and updates them into Kudu table using the put Kudu processor. We are now in a NiFi canvas. As stated, the data flow starts with a process group. So let's drag the process group onto the canvas. I'll name this as generate alerts. Click on add. Go inside the process group and configure the generate flow file processor first. So drag the processor icon onto the canvas and search for generate flow file. Select and add. So we will pass the CM Impala API in the configuration of this processor that will generate flow files with Impala query data. So let's head to its configuration and add three custom properties: from, to, and request. The from and to properties will be fetching the Impala query data executed in the last 10 minutes. The request property refers to the actual CM Impala API. I have just pasted the property values here and provided them in the article for your reference. Let's schedule this processor to run every 10 minutes. So we will set the scheduling strategy as cron and the run schedule as every 10 minutes. Apply. Next, let's place toUpdate attribute processors. Let's drag the processor icon and search for update attribute. I'll copy and paste it again. The first update attribute processor declares two custom variables that converts the from and to property values into an URL-friendly version. It does this by using the URL encode function. Let's configure this processor now and add two custom properties: from encode and to encode. The next update attribute processor brings all the variable properties together defined in the earlier step to form a working CM API string. Let's configure this processor now. And add a custom property called URL. I have provided the URL property value in the article for your reference. Let's connect all these processors together. The output of the second update attribute processor is connected to an output port. So let's drag the output port onto the canvas and connect them. Back to our main pipeline canvas. Next, we'll be placing the control rate processor. So let's drag the processor onto the canvas. Search for control rate. As stated, this processor basically helps with controlling the data flow. Let's head to its configuration. We'll be setting the rate control criteria as flow file count. Maximum rate is 1 and time duration as 30 seconds. This means only one flow file will pass through the processor every 30 seconds. Let's connect them. Next, we'll be placing the execute stream command processor. This processor basically executes a curl command against the Impala API string. So in the configuration, we'll pass the command path as curl. Command arguments is URL. The execute stream command output basically generates Impala query data in JSON format. I have copied a sample output of the JSON data here for reference. So next, we'll be basically using the split JSON processor to split the queries object into a single line object. So let's drag the processor and search for split JSON. Let's configure this processor. And connect them. As we only want to fetch the 7 query elements from the above JSON output data, if you see, this data is inside the attributes object. So to fetch this required JSON content, we'll be using the Joule transform processor. So let's praise the Joule transform processor now. We'll be selecting the Joule transform DSL as shift. In the Joule specification, we are including only the 7 query key elements that we are trying to fetch. I have provided the Joule specification here and in the article for your reference. Let's connect them together. Next, I will place one more Joule processor to add object with the updated time key to the flow file output. So let's drag the processor icon again and search for Jolt. In the Joule transformation DSL, we'll select this as default. And the Joule specification will include the updated time key. Lastly, we will use the put Kudu processor to load the Impala query data into the Kudu table. In the configuration, mention the Kudu master hostnames here. The table name, we will select the record reader as JSON tree reader. Now that we have implemented the entire data ingestion pipeline, you can go ahead and start each of these processors. Let's move to our next implementation step for this use case, that is to connect the table to a visualization tool.